As a security leader, you're not expected to write encryption algorithms, but you must understand how cryptography works at a strategic level. Why? Because cryptography underpins nearly every control in modern security, from identity to data protection, from network protocols to secure software delivery. When you understand the principles, not just the tools, you can evaluate solutions, challenge assumptions, and lead initiatives that keep your organization resilient. So, let's walk through the essential pillars you need to know. When you think about what you're really protecting in cybersecurity, it all comes back to the CIA triad: confidentiality, integrity, and availability. This model is the foundation of information security, and as a leader, you need to make sure your team isn't just quoting it, they're applying it through the right cryptographic tools and practices. Confidentiality means ensuring that only the right people, those with proper authorization, can access sensitive data. You achieve this using encryption, which transforms readable information into ciphertext that's meaningless to unauthorized users. When confidentiality breaks, you're not just risking data, you're risking trust. Integrity ensures that the data remains unaltered and trustworthy. You want to know that what was sent is exactly what was received. Cryptographic hashing gives you that assurance. Whether it's validating software, checking backups, or verifying logs, hashing helps you confirm that data hasn't been tampered with. Availability focuses on making sure systems and data are accessible when they're needed most. While cryptography doesn't directly control availability, it supports it through secure key management, resilient system design, and protection against denial-of-service attacks. If your cryptographic systems are brittle or your keys get lost, availability suffers. Your job is to lead with these principles, not as buzzwords, but as guiding forces behind every control, every design, and every risk decision. Make sure cryptography in your environment is serving these goals, not just fulfilling compliance requirements, but actively strengthening your security posture. When you're leading a security program, one of the most overlooked, but absolutely critical, responsibilities you carry is ensuring non-repudiation. This means making sure that once someone takes an action, whether it's signing a contract, submitting a transaction, or accessing a sensitive file, they can't later deny that it happened. You need to be able to prove who did it, when they did it, and under what authority. That's where cryptographic digital signatures and audit trails come into play. They give you verifiable proof tied to identities and timestamps, evidence that holds up not just technically, but legally. In high-risk environments, legal disputes, or regulatory contexts, non-repudiation isn't a nice-to-have. It's essential. You're not just protecting systems, you're preserving trust and accountability across your entire organization. As a security leader, you need to understand and promote the strategic use of hashing because it plays a critical role in maintaining data integrity across your systems. Hashing is one of the simplest, yet most powerful cryptographic tools at your disposal. It works by taking an input, such as a file, message, or password, and generating a unique, fixed-length string called a digest. What makes hashing so effective is that even a tiny change to the input, one character, one bit, produces a completely different hash. That's what gives you confidence that the data hasn't been altered in any way. You'll find hashing used in several high-impact scenarios. It's commonly applied in file integrity checks, ensuring that downloaded software, system updates, or backups haven't been tampered with. It's vital in password storage, where you never store actual passwords. Instead, you store salted hashes, which makes it exponentially harder for attackers to reverse engineer them. In digital forensics, hashing is used to prove that log files, disk images, or evidence files haven't been modified, which is essential when working with law enforcement or legal teams. Your job isn't to configure the hash functions yourself, but you do need to ensure your teams are using modern, collision-resistant algorithms like SHA-256 or SHA-3, and not outdated or broken ones like MD5 or SHA-1. You must enforce policies that prohibit storing unhashed or weakly hashed credentials, especially in cloud apps, CI/CD pipelines, or internal admin tools. Hashing gives you the ability to trust the integrity of your data. And in a world where trust is everything, your leadership ensures it's done right, from the smallest script to the largest enterprise system. As a security leader, you need to ensure your organization uses digital signatures wherever trust, authenticity, and data integrity matter. Digital signatures combine the strength of asymmetric encryption and hashing to deliver two critical assurances. They confirm the identity of the sender and guarantee that the content hasn't been altered. When someone signs a message or document with their private key, anyone with access to their public key can verify the signature. If the data has been tampered with, or if someone attempts to forge the signature, it simply won't validate, and that's the power you're leveraging. You'll see digital signatures in action across many high-stakes scenarios, such as signing software updates to ensure they come from trusted developers, securing financial transactions to verify intent, protecting legal agreements, and enabling secure email communications. These aren't just technical safeguards. They're the foundation of digital trust. Your role is to make sure your teams understand where and how to apply digital signatures, and that they're built into the workflows, systems, and tools where proof of authenticity and integrity are non-negotiable. When you lead with this in mind, you help create an environment where security isn't just assumed, it's provable. So, what's your leadership takeaway? Cryptography isn't just math, it's strategy. You lead by ensuring that your teams understand how to use it to support confidentiality, integrity, and accountability. You ask the right questions. Are we using strong algorithms? Are we managing keys securely? Are we validating signatures and hashes properly? When you treat cryptography as a foundation, not a feature, you lead a security program that's not only compliant, but truly resilient.